Hello, so I have created a new puzzle. Might be the most difficult puzzle I have constructed, but I really like the idea. So just know what you're getting into here. I don't, it's not on LMD or anything right now, but I think that the difficulty rating would probably be 4 out of 5 stars, maybe 5 out of 5, depending on whether you get certain deductions quickly or it takes you a while. But none of the deductions are unfair. It's just, I think part of the issue is that, as you can see, the grid is a big mess of jumbling arrows and numbers and stuff. And so it can just be hard to find the next step. There is a fairly linear path through, though, and it's completely understandable if you're walked through. So I think it's a fair puzzle, but it's difficult. And this is based on an idea I had, which I actually made a 6x6 version of this puzzle. And then I thought it would work pretty well as a 9x9. And so this is my first attempt to do so. Be interested to see if this particular combination of constraints takes off as kind of a way to do ambiguity / wrong puzzles, whereas some say Roggen puzzles. But anyway, what is this? This is called Something's Very Wrong. It's by myself, Rangsk. So we have normal Sudoku rules. Also, these are standard arrows, but some of them are incorrect. So arrows in the grid can be correct or incorrect. Correct arrows are standard arrows, where digits on the arrow sum to the value in the circle. So if this was a correct arrow, and I had 2 and 3 here, then that would sum to 5. So you'd fill it that way. Incorrect arrows do not sum to the value in the circle. So 9, 8, 1 would be an example of an incorrect arrow. It is up to you, the solver, to determine which arrows are correct or incorrect. Additionally, we have digits outside the grid. These are something wrong clues. And they give the sum of the correct arrow circles. So ignore the arrows, just the circles. They give the sum of the circles. So, for example, let's take the 17 at the top here. If we take the correct arrow circles, so the ones that end up correct, and we sum the digits inside them, they will sum to 17 in this row. And they'll sum to 17 in this column, and they'll sum to 19 in this column, etc. So those are the rules. Hopefully it's understandable. So you got to use the sums to figure out which ones are correct, or other logic to figure out ones that must be correct or incorrect, and then solve the puzzle. All right. So if you want to give the puzzle a try yourself first, there is a link in the description. Definitely check that out first if this at all interests you. And if you do get stuck, you can come back to my walkthrough here, get yourself unstuck. And, if you just want to watch the solve, that's perfectly fine as well. So now's your last chance before I get started on my walkthrough to go check out the puzzle. And so I'll get started right now. And I don't know why, but I'm timing my walkthrough. All right. So I'm just there's a few low-hanging fruits you can do, which we might as well point out, which aren't actually related to the break-in, at least not the immediate one. I'm going to use green to represent arrows that must be true. So these two arrows must be true because our sum is 15. Our correct arrows sum to 15 in this column. And we need 2 circles to get to 15. There's only 2 available. So we might as well fill 6, 7, 8, 9 here, 6, 7, 8, 9 here, because the arrow is cloned there. Additionally, 19 has to be done in 3, so these are all correct. But we don't really know how they add to 19 at this point. But that's basically all you're going to find before we get our break-in. So the thing to think about is row 1, column 1, and column 9. So that's your first hint. If you want to try to figure out the break-in yourself, that might be enough of a hint for you to figure it out. I think it's cool to figure it out yourself. So this is your last chance before I just immediately tell you. So now we're gonna find out what the break-in is. So first, let's think about this column on its own. So whichever ones are correct in this column sum to 17. And so I guess I should point out that if this arrow were true, it can only add to 9. Because the minimum here is 1, 2, 3, the minimum here is 1, 2, that adds to 9. So if this is true, it has to be 9. That's the one thing to point out. Another thing to point out is these can't all 3 be true. If all 3 of these were true, then there's a few arguments you can make. You can case check, whatever. The easiest argument is parity. the sum of an arrow and its circle is always even. So this is even, the sum of this is even, the sum of this is still even. But the sum of the digits in a box is 45, which is an odd number. So if all three of these were accurate, then the puzzle would be broken. So we can't have all three of these in. And so now the question is, can we do three of them? If we want three of these arrows correct, then we can only use two of them from this box. We must then include this one. But we know this one would have to be a 9. So we'd have only 8 left in this box. And the sum of 4 digits is minimum 10. 1, 2, 3, 4 is 10. So these would sum to minimum 10. We'd get up with 19, not 17, minimum. So if what that means is we're always going to be using exactly 2 of these circles. We're either going to use 2 in this box with an 8-9 pair, or we're going to use this, which is a 9, and there's going to be an 8 in this box. So again, the box is either going to be an 8-9 pair somewhere. We don't know which 2, but some of these, 2 of these would be an 8-9 pair. Or this is a 9 and it's correct, and one of these is an 8. Okay. That's exactly true on this column as well. This column is identical. So you can use the exact same logic to go, that would be the same as well. So the next thing we can prove is that what we can't do is something like this, where we have 2 8-9s down here, and both of these are wrong. The reason we can't do that is because if we sum up 8, the sum of this 8, 9, 13 is the sum of the correct circles in this band. And 8 plus 9 plus 13 adds to 30. Because they add to 30, 8 plus 9 plus 8 plus 9, that's 17 plus 17, that's 34. This would already be summing to too much. One of these clues would have to be wrong, or more than one would have to be wrong in order to use 8-9s like this. Another way to think about it is you'd have to have some 8-9 overlapping, right? Either these 8-9s will overlap, or like, there's no way to have 4 8-9s down here without some of them overlapping, which would cause a 17 sum in the row, and that's not going to work either. So the conclusion is, one of these could be 8-9, but they both can't be 8-9 in any formation, which means one of these has to be true. One of these is a 9. We don't know which, but one of them's 9. Now, they can't both be 9, and so that means that down here, we're going to end up with, we know exactly the contents of our columns. We're going to have a 9 with an 8 in one of these, and then we're going to have an 8-9 pair in the other. So we can now think about that. So these arrows are only made up of 8s and 9s. And so how are we going to do these sums in the rows? Well, one of these is going to be 8. One of these is going to be 9, because we can't do 8 and 1. And then one of these is going to be 8, because the 9's now used up. We only get 1 9. We have 1 9 and 2 8s down here. I should have sort of mentioned. And so one of these is 8, which now we know that because this one's in and one of these is in, that's an 8, and the other one's not in, this has to be a 5. So we have our first digit, which is a 5. We might as well fill 1, 2, 3, 4 here. So that's kind of the initial break-in, and you actually get a few digits out of that. The thing to think about, there's a few ways to think about it. You can calculate the outies, because we know these add to 19. But you can also just think about actually, we should think about row 1 first. Actually, sorry. Got a little ahead of myself. Well, let's think about row 1. So row 1 is also 17. And we know one of these is 9. Now we know one of these is a correct 9. So we need 8 more only. And we can use the exact same logic we use down here. If we need to add to 8, we can only use a single arrow. Because if we start using 2 arrows, then that means that this would have to add to 8, but it's minimum 10. And we happen to know which one's correct, so we can just fill an 8 in there, and these 2 are wrong. So I'll use gray for wrong. And so now the 8 and the 5, those add to 13, so we need 6 more, so that's a 6. So these are not 6s. And we know with these 2 add to 15, so this one's not a 9. And so, right, so now what we can think about is how do we add to 8? We could be 1 7, we can't do 2 6, we can't do 3 5. So this is only 1 7, which leaves 2 3 here, and then the remaining digits are 4 9 in the column. This 4 9 pair sees here, removing 9 from these. And now we can look at row 3. Row 3 adds to 9, so that means this one has to be correct, and it has to be a 1 or 2. That transfers here. Now to add to 6, which we know is correct, this needs to be a 4 or 5. Okay. So The next thing to spot is that this is now a 1 or a 2. So how could this be 9? If this is 9, this has to be 1, 2, 3, and now we have too many of that in the box. So this is not the 9. This is actually incorrect, and this is the correct 9. And that gives us this correct 9 as well, and this is an incorrect arrow. And we still don't know how these 8s are arranged, but we did get some digits here. And so now we can actually fill 1, 2, 3 here, and we can fill 1, 2 here. And now there's a few ways to prove this, but this arrow cannot be correct. If it was correct, what is the minimum these sum to? 3, 4, 5, 6. 3, 4, 5, 6 is 18. These two would have to add to 18, so this would have to be at least 10. So this cannot be correct. It is incorrect now. This being a 7, 8, by the way, makes this a 7, 8, because these add to 15. And so now we think about... so we might as well fill that this is 3, 4, 5, and that one of them is 3. Not too important, but it's true. Not too important at the moment, at least. Okay, so the next thing to see, which you could have seen it earlier as well, but I'm pointing it out now, column 7 adds to 9, and so this is only 1 or 2, and there's only one other circle in the column, so this one has to be true, and that makes this a 7 or an 8. This has to be 2 or 3 to achieve the 7, 8 sum. 4 would be too big, because 4 would force 5, that would add to 9. 1 would be too small, max would be 6. So it is 2 or 3. We can do 5, 2, 7, we can do 4, 3, 7, or we can do 5, 3, 8. So now we know that in this row, that adds to 26, these two add to 15. We have 3 circles left. So 15, what's left is 11. We need some of these circles to add to 11. We know that at least 2 of them are in. So let's think about whether it could be just these 2. Can this one not be in? Let's pretend this one's not in. How would these 2 add to 11? Well, there's only a few ways to add to 11. The 7, 8 pair and the 6 prevent all of them, and then 9. So 11 could be 2, 9, but there's a 9 already in the box. It could be 3, 8, or 4, 7, but there's a 7, 8 pair. Or it could be 5, 6, but there's a 6 in the box. So these can't actually add to 11, which means this one must be in, or we're not going to be able to achieve our 26 sum. And now this might be a place where you got stuck. I know a couple testers did, and so this might give you a nudge to get some progress. Think about, where does 9 go in this box? This 9 sees up, and we know this arrow's true, so these can't be 9, and we've marked none of these as 9. So that means this cell has to be 9. This arrow adds to 9. That gives 4 and 9. Oops. And then we can think about, where's 9 in this row or 9 in this box. Either way, you get a 9 here. Okay, and then you should get some more digits out of this. Yes, okay, so the next thing to look at is now these add to 24, which means we need 2 more. We're not going to do 1 plus 1, so one of these is correct and is a 2. This 2 claims this value, so this is a 1. That gives us 7 and 1. That makes this an 8. That makes this a 7 and this an 8. The only way to add to 8 is 5, 3. So we're going to fill that. This needed a 3, so that's 3. We know it adds to 7, so that's a 4. This is 2 and 1. Getting a bunch of digits. That's a 1, because of the 2, 3 pair. How are we doing on 1s? So we have a 1 down here. Oh, right. We know that one of these is a 2. So that means we have a 1, 1 here or a 1, 1 here. So there's definitely a 1 in one of these two. And this 1 sees down. So that actually gives us the 1 and the 1 down here. This is the 2. This is wrong. This is right. Let's see. At this point, there's probably a few things you can do. Let's pencil the rest of this band, because I think a lot of it resolves. So we have 1, 2, 3, 4. We need 5, 6, and 8. The 8 is placed. Here we have 3 digits left. The 3 sees in, so this is going to be a 3. And this is going to be a pair. It's going to be a 5 and a 7. Okay. We could ask how we're adding to 9. So let's get this pair first. This is 2. Oh, no, not 2. Sorry, there's a 2 in the row. 1, 2, 3. This is 4 and 7. And we can't do 4, 5 adding to 9. So we're going to do... Whoa. Sorry. We're going to do 7, 2 adding to 9. This is a 4. This is a digit. This is a 1. And this is a 6. All right. So we have most of this band done. There may be a bit more. Yeah, so this 4-7 looks up, making a hidden 4-7 over here. And this 7 sees in, telling us which order it is. This is a 5-6 remaining. That gives us a 2-9 pair down here. All right. There may be a little bit more Sudoku to do, but at this point, I'll give kind of the next major step. I know that was a lot of Sudoku. So much Sudoku in the Sudoku puzzle. So let's think about these 8s here. One of these is an 8, and one of these is a 2. The 9 isn't going to help with the 8, so the 2 must help with the 8, which means one of these is going to be 6. That does look up, giving us 5 and 6 here. So we know that the 8 over here is going to be 2, 6, 8. We don't know which one, but one of them will be, which should be helpful. Additionally, we have this 9 over here. How are we adding to 9? Well, we can't do 1, 8 because one of these is an 8. Also, there's a 1 in the row. In fact, I think we can place our final 1, which will help later. Yeah, the final 1 goes here. All of our 1s are placed. Anyway, let's go back to this 9. Can't do 1, 8. 2, 7 is not possible because there's a 2 and a 7 looking at this cell. 3, 6 can only go this way because of this 3, and 4, 5 can only go this way because of this 5. And so now this is a place where a lot of people get stuck as well, I think. But I'm just going to give the cleanest way to think about this, which is, what would happen if this were an 8? So if this was 8, we'd have 8 and 7. I'm just going to write it out. You can see this in your head pretty easily, though. And we have a problem now, because this 8 we know is 2, 6. I'm going to write it out. And now there's nowhere for 2 in this box. This 2 sees over. This 9 can't use a 2 in its sum, so it's broken. So you can kind of ask the question. There's a few ways to see this. That's one way to see it. Another way is you can ask the question of, where does 2 go in the box? Well, if 2 is up here, then I guess we can think about which one's the 8 sum. If this is the 8 sum, 2's up here. If this is the 8 sum, there's actually only one way to add to 8 up here, which is 2, 6. Because we can't do 1, 7. There's a 1 down here. And we can't do 3, 5 because this 3, 5 looks down. Or break this 3, 5, however you want to do it. And so the only way is 2, 6. And so if this is an 8, the 2's up here. If this is an 8, the 2's up here. So the 2 points, it makes that a 9. And that also resolves things. So let's make this a 9. Let's make that a 2. There is another way to see it, which I think is kind of neat. So let's go over that as well. It requires you to realize that this is a hidden 8 in the row, which isn't that hard. You probably saw this 8 X-wing and marked 8s, corner marked them 8 here. And so when you got this 8, you could place this 8. And then the other thing you kind of have to realize is that if this is the 8, it's 2, 6. And if this is the 8, it's 2, 6, making this 3 and 2. Once you get that, you know that the 8 and 2 are always going to be together in a row. Because this is either going to be a 2, 8 up here or a 2, 8 down here. This is always 2, 8. And so the 2, 8 and the 2, 8 see up here, or the 2, 8 and the 2, 8 see down here. But you can't actually do 2, 8 down here. So this can't be 2, 8. So that's another way to see that. So this is the 2, 8, the 2, 6, 8. This is a 9. So I think that last one is kind of a neat way to see it, but it's probably not the easiest way to see it or the cleanest way to see it, but I like it. So anyway, this 8 we already know is a 2, 6, and it only has one way to go. This is 4, 5. And it's just Sudoku from here, however you want to finish it. So let's do so. We have 1, 2, we need 3 and 7. So this is 7, this is 3. Here in this row, we have 1, 2, 3. We need 4 and 9. Sorry, we should mark that these 2 are the correct arrows and these 2 are the wrong arrows. This is 1, 2, 3. We have 4, 5. We need 6 and 7, so we know the order because of this 6. That gives us the 5 and the 7. Over here, we need a 3, so the 3 goes here. We need a 4, and the 4 goes here. We need a 5, which goes here, and we need a 7, which goes here. Okay, we got some triples up here that we can fill. So we've got 1, we need 2, 5, and 7. The 7 is placed. Up here we have 1, 2, we need 3, 4, and 8. This is the 3, 4, and 8. Up here we need a 9. The 9 goes here, and we need a 6. Gives us 5 and 6, 2 and 3. This is 5 and 2. And then just, we can finish this box up. So we need a 2 in the box, which goes here. We need a 3 in the box, which goes here. We need a 4 in the box. We don't know yet. It's one of these. Sorry, one of these. We need a 5 in the box, which is also one of these, but it actually has to be this one. So that's 5 and 4. That's 9 and 4. And finally, we need a 6 in the box and a 9 in the box. So they just go like that. And there we go. That should only take you 18 minutes to solve if you know exactly how to solve it. All right. I did spend a while explaining that last ending because I think there's a few cool ways to look at it. But I hope you enjoyed this puzzle. Definitely, I think it's definitely the hardest puzzle I've published, especially in a while. Not that I published very many, but I really like this idea. And I think at least the idea of having sums outside the grid that inform you the sum of the correct clues, I think that has some legs. So I'm interested if any of you get inspired and decide to also use this rule set. This wasn't very easy to construct, but I think it was rewarding. So yeah, let me know how you felt about this puzzle. Hope you enjoyed it. And if you did, why not give a like, subscribe, kind comment below. And if you're not aware, I do live stream Sudoku twice a week. So check out one of my live streams as well if you're able to. And I'll see you next time.